All right, ladies and gentlemen, we're going to start with enamine review and then see how it ties in with the enolate chapter. Because enamines behave like enolates. And we're going to share. And move this guy out of the way. And here's a secondary amine. Secondary amines react with aldehydes or ketones. In this case, ketone, to make enamine. This one is the less substituted enamine. And this one's the more substituted. Enamine. More substituted, more hyperconjugation. Major. Wasn't asked for, I should have asked for it. Circle major. Here. A. Circle major. B. Look at that. Good retrofit. Okay. For each step below. Yeah. Enamines, lone pair, pushy. Attack carbonyl. Get greedy or not? Let's not. Just do. We could have done two steps, but you know, sometimes we'll go a little slower. Methyl. O negative. And with H, ammonium ion. And you do this and you lose a point on the test. What? That's not nice. How do you get your point back? It's not like you lose a point. I wouldn't give you the point for this part of the mechanism. So I guess you did lose a point. You can't reach the H. That's all I'm trying to say. Over this arrow, you got to say, you know, it's between two different molecules that are exact twins. A second molecule. And then you make this amino alcohol here. Amino alcohol. Nitrogen's pushy again. Got its lone pair back. Pushy enough to kick off a lousy leaving group. In this case, hydroxide. And we made an iminium. Easy for me to say. You need two copies. One of them is going to give the major, one of them is going to give the minor. You have H's here and here that hydroxide can take. Plus OH negative. When you made each one, you made OH negative. Grab alpha H, resonate to your enamine. Grab alpha H, resonate to your enamine. Top one goes to major, Maj. This one goes to min. Min. Maj. Min. enamines. I'm going to use the enamine on the top right in a Claisen. How do I know Claisen? You're attacking an ester. Attack ester equals Claisen. Attack aldehyde or ketone. Aldol. And how do I know this is an aldol condensation? I got heat. And I made an alpha beta unsaturated pi. Lots of clues that this is the condensation and not the reaction. The reaction creates an aldol, it has an alcohol. Yes, you're going to be making the alcohol, but you'll be getting rid of it too. That's the condensation. Since we're down here, let's do this one first. Enamines are nucleophiles, not at the nitrogen, but at the alpha position. That's the end of the ene. Resonance says this. The nitrogen lone pair is pushy, but it's going to resonate and make the carbon the nucleophile. So it's acting like an enolate. And here we go. So you're going to have this double N, new bond, very exciting. O minus and isobutyl. And now I will resort to red first, because you got to finish the aldol reaction first to make an ol. That's an alcohol. But in the first step, there was no protons around to do so. You need to add a proton. That's where your sulfuric acid comes in here. I should be nicer. And in both of these, I should say excess. 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 Sorry. Got rid of the page for you. There you go. So mole number 1 of sulfuric acid is going to do this lickety split acid base reaction. That just means fast. We still haven't found out the origins of the expression lickety split. We'll work on that some other day. Sometimes you don't like when you find these things out either. We got some bad stories. All right. We do have to get towards a carbonyl, don't we? Take a look at the product. Where's this O going to come from? H2O. Let's do that as a second step. And let's see if we can get even more ambitious. Because you're going to make sulfate here. All right. And H2O, lone pair. Second color. Blue second. And then you're going to get an oxonium, right? So just summary of what we got so far. I got that. The O is going to be an oxonium, but I'm not going to draw an oxonium. No siree. And then we're going to have OH, IBU. Where'd the second H go? Off water. What took it? OH has another H. Where to go? H2SO4. Go with purple. Implied step 3. Don't even have to say it. It's not red. It's not blue. Although on the screen it might look a little blue. No, it's purple. There you go. And now it's time to strip off the old ammonium ion. H2SO4. This is hydrolysis. And OSO3H, which we haven't made yet. Step 1, protonate. Make better leaving group. Sulfate ion also happens. Might need that, don't know. Nitrogen's lone pairs back. Step 2. But what are we late? We're not getting rid of OH. In my mind, I was getting rid of OH. That's why I protonated it. Tell me how to fix this. We're not getting rid of OH. What are we getting rid of? N. Please protonate the N. It's a better base anyway. I don't know what happened to my brain. We're gonna need some surgical erasing here. Just the beginning of this arrow here. Yes, the surgeon seems to have had a hammer here. There you go. Protonate the N. Now it's a better leaving group. After it's a better leaving group, you can do this. Make it leave. Looks like elimination. Blue second. Okay. Oh, it doesn't look so good. That's it. Protonated ammonium ion there. Let that sink in. Oh, we're not. We don't have the product. My goodness. We have the Aldol product. We're not there. The Aldol product is on the way to the Aldol blank product. What's blank? Why does it do that? Really? There. Sigh. We need to make this from this. What's got to go away? Talk to me in Greek. Does anything have to leave the alpha position? Answer, yes. The alpha position has an H on it. We don't have hydroxide in this mechanism. The best base we have is sulfate. You will not be using sulfate to deprotonate anything before you make this a better leaving group. What's going to be used to make it a leaving group? Kind of what I did accidentally a few seconds ago. Sulfuric acid. Protonate first. Then you can use this bad base, this poor base, to eliminate the water. That goes to the product. Oh yeah. So we just did a directed Aldol condensation. Aldol condensation. Right there. And Claisen's going to be up top. We'll see how that goes. Ready? There's our enamine again. It's got a lone pair. What did the lone pair do last time? Take a look. Where was it? It was down here. I know. It's hard to follow when I do that. Ah, resonate and attack using the pi electrons to the alpha position. So the alpha position ends up with a new bond. Let's do it. This time the alpha position is the other one. Up here. Resonate. And attack. I don't like the way that worked out. Attack. That's better. Pi breaks goes here. There's a leaving group this time. Not a great one, but good enough. And let's do it. Here. Here's your N. And we got this. Yeah. So the top part of the molecule looks great. It's got what we need. Bottom part has to break apart using water. What's that called? Breaking apart using water. Hydrolysis. Once again, we had hydrolysis already. We did acid base here. And we did, it looked like blue and purple started it. Blue and purple, yeah. Blue and purple. Up here, driving you nuts with all this stuff blown up. Hydrolysis only. Now, normally, because we made a base, you'd be thinking about taking off an alpha H between this alpha, sorry, this thing here. If you had to guess the pKa, if there was an H here. In your mind, you have an H there. It's kind of alpha to a carbonyl and an iminium. I'd say it's somewhere in the ballpark of 10. If there was an H there, I'd have to take it off. You can't stop it. There is no H there. You don't have to take it off. Okay, that's all I'm saying. Normally in a Claisen condensation, the next step is to take that H. All right. Hydrolysis starts with water and sulfate ion, water and black. Some future sulfate ion. And at this time, sometimes a student will ask me, where'd sulfate come from? Ladies and gentlemen, if you put a strong acid in water, you have more sulfate ion than sulfuric acid, because sulfuric acid reacts with water. There's tons of sulfate ion. Anytime you have a strong acid, you can just use its conjugate base without even showing me it being made. All right. So water is an attacker, and I'm going to reassess my original water because it's going to lose an H eventually. Coming in from underneath there. Sulfate ion, different color, we're fine. Some other students might say, wait, you had a better base here. You should have used this base, Dr. Whittaker. Okay, to those students, I'll do this step, which you don't have to do on your mechanism. The first thing that happens when you add sulfuric acid is a side reaction to get rid of methoxide. And you can say, now I'm happy because sulfate's not a mystery anymore. But once again, what I said before still holds. You can use the sulfate as you see fit. And I'm just going to do this because you didn't have to do it. I'm not saying it didn't happen, but it's not necessary to do side reactions unless I tell you to. Not necessary to show. Okay. But moving on to the task at hand, we're well on our way for the hydrolysis. Could have done an R group circle a long time ago, I guess. I got an amine that needs to leave. So let's make it a better leaving group. And let's use a base to grab the H after we do the leaving group improvement exercise. Protonation makes things better leaving groups. Elimination gets rid of them. Oh, crossing arrows. Sorry about that. There you go. And somebody's going to say something in a second. Or I'll say it for them. You'll see that I have two different finishes to these things on the same page. I like this finish here, I think a little better than the one that was here, where the nitrogen left. Well, let's see. It's not being an NH2 plus, is it? I changed my mind. I think I like this one a little better. But this one's fine. You would make this nitrogen, which will not hang around under the reaction conditions. So I'm going to do what I did earlier and say, it's a side reaction. You don't have to show me. But this would protonate with sulfuric acid present. It would protonate. That's what nitrogens do in strong acid. And once again, not saying it doesn't happen, but it's not necessary to show this. Okay, I apologize. I think I'll sign off before I pick up my pen. There's a lot going on here. Big day today. The hydrolysis gets split up. Hydro. Oh, the ISIS is above it in purple. I didn't move it. I see what happened. I don't think I can fix this thing. Yes, I can. There, it's pretty. So what we're gonna do is stop this. And that's the end of today, because I have a 2:41 exam. I gotta get the room ready. So you guys got a little early exit today. So here you go. And